So we had sine 3 theta equals, we're trying to verify it equals 3 sine theta minus 4 sine cubed theta. So we break up sine of 3 theta into sine of 2 theta plus theta. Then that allows us to be able to use our sum and difference formulas, right? So right here, we're using the sine of A plus B, or alpha plus beta. So we're using that identity at this step. So that's going to give me a sine of 2 theta times a cosine of theta plus a sine of theta times a cosine of 2 theta. That's the sum formula for sine, and that's to be in the toolkit. So that's what I did to get that step. Does that make sense so far? Everybody cool? Okay, now, for the sine of 2 theta, I only have one choice, one formula to use for sine 2 theta, and that gives me 2 sine theta times cosine theta. Okay? So that's that part there, and then I still have a cosine theta on the outside. So this piece right here, this became this. The blue became the blue. Right? Because that is the double angle formula for sine. And I still have cosine on the outside. Okay? Then I have a plus, I have a sine theta. Alright, now I want to change this piece, this cosine 2 theta, this yellow piece, into something that I can actually use. And I want my answers to be in sine. So could I change cosine 2 theta into something that only has a sine in it?
1 minus 2 sine.
There you go. So that's going to be 1 minus 2 sine squared theta. Right? So that piece became this highlighted piece here. To help you guys out and highlight them along the way, which one becomes which? Okay, so now I'm going to distribute my cosine in. So I'm going to get 2 sine theta cosine squared theta plus, I'm going to distribute my sine in. I'm going to get sine theta minus 2 sine cubed theta, because sine times sine squared is sine cubed. So far so good? Everybody still on board? Okay, now I'm going to deal with this right here. I have to deal with a cosine squared. So what can it become? In terms of sine, can I rewrite it in terms of sine?
1 minus 10.
There you go. So I have 2 sine theta times a 1 minus sine squared. Theta plus sine theta minus 2 sine cubed theta. Awesome. Then I'm going to distribute, and I'm going to get 2 sine theta minus 2 sine cubed theta plus a sine theta minus a 2 sine cubed theta. So now in terms of like terms, there's 2 sine theta there, there's 1 sine theta there. How many sine thetas in total do I have? Yeah, I have 3 sine thetas, right? And then if I take a look at these ones, right, I have a negative 2 sine cubed there and a negative 2 sine cubed there. So how many do I have total? 4 sine cubed thetas, which is exactly what we're supposed to show at the top. The power reducing formulas, they are, if they're not in your toolkit, make sure you put them in there. We have sine squared theta is equal to 1 minus the cosine of 2 theta, all divided by 2. So that's one of them. The cosine squared of theta is 1 plus the cosine of 2 theta, all over 2. And the tangent squared of theta is, hopefully you guys noticed this, it was the quotient of the two numerators right on top there. So it is 1 minus your cosine of 2 theta, all divided by 1 plus your cosine of 2 theta.
Oh.
I know you're okay. So cosine before theta, we're going to rewrite the expression so that it does not have any powers higher than 1 in it. All right, so here is the deal. We'll go one step at a time, take it nice and slow. You guys cool with this? We can rewrite this as cosine squared theta, all quantity squared. Everybody see the algebra involved with that one? All right, fair enough. So far we've broken a fourth degree down to squareds and then squared. All right, cool. Now, does cosine squared theta, do we know what that one is? We sure do. It's this piece right here, right? So I'm going to take that and I'm going to square that. So that's going to give me 1 plus cosine 2 theta over 2 all quantity squared. So far, so good? Yeah? Okay, good. Then we're going to apply my exponent to the numerator and the denominator. Okay? That's going to give me on the top, if it's 1 plus cosine 2 theta squared. So that's going to be like 1 plus cosine 2 theta times a 1 plus cosine 2 theta. So that's going to give me 1 plus, multiply the two pieces together, and then double it. So 2 cosine 2 theta plus the last thing squared, cosine squared of 2 theta. All divided by the denominator squared, which is 4. All right, so more algebra stuff, more heavy algebra stuff. Everybody see where my numerator comes from? Yes. Okay, so I'm going to break up this fraction. This is going to be 1/4 plus. If I do 2 cosine 2 theta divided by 4, I get 1/2 cosine 2 theta. And then I'm going to move this over so you can see. And then I'm going to do plus 1/4 cosine squared 2 theta. So I broke up the fraction and moved those coefficients out in front of all of my terms, okay? All right, now it's time for a little sidebar here. So I'll keep moving this over to the side. So I'm working with this piece right here, okay? We know that the cosine squared of theta is 1 plus the cosine of 2 theta all divided by 2, right? Everybody knows this part? I wanted to point out that this theta and this theta match, right? Okay, the reason I'm doing that is because I want to show you, set you up for the next one. If that's true, then what must be the cosine squared of 2 theta? 1 plus the cosine of 2 times 2 theta, all divided by 2. So what would that be then? 1 plus the cosine of 4 theta over 2. Now, why did I teach this little sidebar thing? Because you'll notice that it's right here. Do you see that? A cosine squared of 2 theta is going to become all of this stuff right here. You guys with me? Okay, so I'll come back over here and I'll rewrite that in. So this is going to become 1/4 plus 1/2 cosine 2 theta plus 1/4 times this stuff that we figured out. 1 plus cosine of 4 theta over 2. We are almost done. The last thing that I do is bring that 2 out. So 1/4 plus 1/2 cosine 2 theta plus 1/8 times 1 plus the cosine of 4 theta. So check that out, you guys. There is no term in our new expression that has a degree higher than 1, and that is what we were asked to do. So I'll shrink this down so we can see the whole problem. And actually, there it is. It's not that bad from start to finish. So on your own in your groups, rewrite sine to the power of 4, sine to the 4th of theta, as an expression that only has powers of highest degree of 1. All right, so I'll make sure everyone's on the same page. Most people got to here, with no problems. Where am I right now?
Wait, why did we made it into 1 plus cosine x squared?
Yeah, you can do that. But then
No, you can do that.
Oh, because I didn't.
Yeah, so 1/4 minus 1/2
Oh, you separate them, I see.
cosine 2 theta plus 1/4 cosine squared 2 theta. Yeah, the only difference here is the minus sign, right? Just wanted to give you guys another one to work on.
Can I do one more time?
Yeah, so what did you do with cosine squared 2 theta? That's the next part. Because everything else has a degree of 1. What do you do with this one? So you should get 1/4 minus 1/2 cosine 2 theta plus 1/4. What'd you guys change this to? Cosine squared of 2 theta. Yeah, it should be 1 minus cosine 4 theta over 2. Actually, it should be plus, huh?
Yeah.
Should be plus, thank you. Yep. So then the final answer you guys should have come with should be 1/4 minus 1/2 cosine 2 theta plus 1/8 times 1 plus the cosine of 4 theta. And it's exactly the same thing except for that minus sign right here in the beginning. Yes.
Yeah.
Okay, these should already be in your toolbox, but just want to make sure that if they're not there, I want to at least talk about them, right? So sine, these are called half angle identities because we are taking a theta and we are cutting it in half. So far we had double angle identities, half angle identities, sum identities. There's only one choice for cosine and sine. However, you do get 3 choices over here for the tangent. And you might not have all 3 in your toolbox, so I at least wanted to make sure that you got these other 2, probably these ones over here in blue. These ones are probably not in the toolbox, so make sure you get them in there if they're not already. Okay? And those are the easier ones to use because they don't deal with that big old nasty square root. Okay? Now the other important piece of this puzzle is this plus or minus. See how there's a plus or minus in front of all these? That one, and finally that one. Okay? The plus or minus refers to whatever quadrant theta over 2 is in. So you have to figure out what quadrant theta over 2 is in, and then take the appropriate sign, positive or negative, depending on whichever one it is. All right? So these, just a review, should be in the... All right, so directions are, find the exact value for the cosine of 112.5 degrees using the half angle identities. Okay? So let's conceptualize what we're trying to do. Where is 112 degrees? Or 112.5 degrees? Where is that? What quadrant is that in? It's in quadrant number 2, right? So if I draw an angle that's in quadrant number 2 and call it 112.5 degrees, okay? And I want the cosine of this angle, should my answer be positive or negative when I'm all done? If I'm in quadrant 2, cosines are... Cosines are x values and they're negative, right? So my answer should be, if I want the cosine of this thing, it should be negative, right? Whatever it should be negative. Negative because I'm in quadrant number 2. Okay. That being said, right, 112.5 degrees is exactly half as much as what? 225, right? And 225 degrees is an angle down here in quadrant number 3. And that is a nice, easy angle to work with because we know the exact value for 225 degrees. Is that true? Yes, we do, right? So what's the cosine for 225 degrees? No, not, I want the value. What's the cosine of 225? Negative root 2 over 2. Good, what's the sine? Negative root 2 over 2, right? That's a 45-degree reference angle in quadrant number 3. This one we actually know, right? We know the exact value for the cosine of 225 degrees. We're trying to figure out the exact value for 112.5 degrees. So we're going to use the fact that it's exactly half of something that we know to come up with it, okay? So here's our game plan. We're going to let theta be 225 degrees. That's the one that we know. Okay, so therefore we can say that the cosine of 112.5 degrees is the same thing as the cosine of 225 degrees over 2. Everybody still cool on board with that process? Yeah. Okay, good. Now, this is a half angle identity. So if it's a half angle identity, I'm going to go ahead and use the fact that I know a half angle identity is, right? Oh, look, there it is. I can use that one. So nice. So now, should I use the positive one or the negative one, you guys? The negative one because I know my answer should be negative, right? So therefore, this is going to become the negative square root of 1 plus the cosine of 225 degrees, all divided by 2. And I got that straight from that box right there. 1 plus cosine theta over 2. And notice that the theta that I used was the one in the formula, the 225, because that's the one that I know, right? Is this making sense to you guys? Okay, good. So it's going to be negative square root of 1 plus, okay, what's the cosine of 225? We figured it out earlier. What is it? Negative root 2 over 2, right? Good. So this is the negative root 2 over 2. Good. And then all divided by 2 in my denominator. So all we have to do is the algebra part and fuss with the algebra here. So this is going to be the negative square root of, I'm going to have 1 minus root 2 over 2 all divided by 2. Okay, we're going to use that trick right there. The 1 plus a over b trick. What's the numerator going to become, you guys?
Wait, how did you get plus
2 minus root 2 over 2.
Very good. So it's the negative square root of, I'm going to have 2 minus root 2 over 2. And then can I flip and multiply?
Times 1/2.
Very good, Ethan. Times 1/2. You're seeing all that algebra at once. Very good. That's where you should be. Okay, so moving up here. I'm going to get the negative square root of 2 minus root 2 over 4. Right? I'm going to finish this off by saying it's the negative square root of 2 minus a root 2 all divided by the number 2 because the square root of 4 becomes 2 when I break up my radical. And that is the exact answer for the cosine of 112.5 degrees.
So we just expect to have these really like not completely solved answers.
No, what do you mean not completely solved?
I mean, like just don't like the radical.
Okay, same directions. You can do it on the table if you want. Find the exact values in half angle formulas for the sine of 105 degrees. Last one, you